Hello, everybody, and welcome. I'm Dr. Mark DeBrinket, the Good News Doctor, and today I have another episode with Robert Long and Dr. Hans Vink. These are owners of the Glycocheck machine and the MyBodyRx and Microvascular Health Solutions, these amazing products that they have brought to the Bioregenix company. And we are just so excited to be on our third podcast now. So I had both of you gentlemen on last summer, and we talked about the Glycocheck machine and all the studies that have led to proving that damage in your endothelial glycocalyx is going to lead to all sorts of conditions. And then we ended the episode with saying next time when we come back, we're going to talk more about the studies that came out this year as well, but we're going to talk about the endocalyx and endocalyx pro and what that has done to so many people's lives and what we're seeing in the actual studies. So thank you guys for coming back on, and let's get to business. What's going on new with the studies from this summer since we've spoke last?
Well, great. Thanks, Mark. And again, I'm really thankful to be partners with Dr. Vink. He and I started working together many years ago. And I have to say, I think we constantly count our blessings because this whole movement that we've been involved in and we're a pioneer in of microvascular health is accelerating. And we get contacted every week now by academic research hospitals that not only want to buy a Glycocheck, but they ask us if we would have an interest in doing studies on so what do you do about it, the endocalyx product. And so not only have we been able to do a lot of additional studies with the Glycocheck, which I think Hans will touch on, we're across the most exciting thing for me, and I knew this years ago when I came into this, is I knew that the thing that got me so excited was that one thing that we focus on could impact so many different things about our health. And it's, a lot of people, talk about, it's the one, but this is really the one thing that until you fix it, until you know how healthy it is, you really don't know what your health situation is. And so, we were patient. We've put in all these years. I know Hans had to first figure out what was the glycocalyx. Had to get the images. A lot of doctors are out teaching and showing our slides that Hans and his PhD students captured even 20, 25 years ago. And that changed the whole trajectory of what we know about the human body and the importance of the endothelial glycocalyx and its role in health. And so for me, it's just so exciting because when we started out together, our goal was to get a bunch of academic research behind us. And it's just snowballing, like it's so exciting. And then as we created the endocalyx pro product, we knew that we had something special, but every time we do a study, the thesis that we go into it with, it proves to be true. And so we're excited to share this information with you today. So with that, Hans, I know you've got a bunch of stuff prepared, so I'm going to turn it over to you.
Well, thank you, Bob, and thank you, Mark, for inviting us again. It's so good to be here. I realized the last time that we talked is not too long ago, a few months ago, and then we shared some of the exciting data of studies that we did with the Glycocheck system, showing a lot of problems in different diseases. So what I would like to do today is circle back a little bit to those findings that we discussed last time, and even the last few months. Some exciting additional data was published. Not only on the prospective studies that we showed that we can predict future risk for stroke or future risk for heart attacks, but also new data on COVID studies, and also very exciting data on people with diabetes, also showing that even during pregnancy, people that develop diabetes during pregnancy, that even 10 years later, they still suffer from microvascular problems. So again, that illustrates and underlines the need that we offer some therapeutic to people that are suffering from long-term microvascular damage. So there's a lot of studies ongoing, and unfortunately, I cannot share too many details of the studies that are still in progress. But what I can do is show in more detail one of the finished studies on aging, and another finished study that was recently published, an experimental study on the protective effect of endocalyx against COVID challenges. So with that, I think it's going to be a lot of additional new information compared to the last podcast that we recorded. So one study that we discussed last time was a large-scale study on 600 or 700 healthy individuals in a prospective study in collaboration with the cardiology department in Greece. So 7 years ago, we measured all these healthy individuals, and then we demonstrated during follow-up over the last 6 years that people with a compromised microvasculature as measured with the Glycocheck device, so that's shown on the lower left with a high PBR score, so a damaged glycocalyx, those individuals with a compromised microvasculature 6 years ago, during follow-up, they had a much higher risk, a 5-fold higher increased risk of getting a stroke or a heart attack or a cardiovascular related death. So more recently, this study was followed up, just published this year. And again, people using the Glycocheck system and measuring microvascular health during the actual stroke, an actual stroke or a transient ischemic attack. So what's shown in these graphs, so on the left is showing a significant decreased capillary density, compromised and damaged microvascular systems in individuals that are actually experiencing a stroke. Similarly, on the right-hand side, also people experiencing what's called a transient ischemic attack. So it's a short duration stroke, also showing a very significant loss of microvascular health in these individuals. So this study that just came out confirms that not only we can predict, in healthy individuals who has a higher risk of getting a stroke, but also measuring in people that are having a stroke, again confirming that these individuals indeed have a significantly compromised microvascular health, which we now know makes them not only much more vulnerable, but also contributes to the risk of getting the stroke at the moment that they're having the stroke. We already showed that in adults experienced to COVID, there's significant microvascular damage. So on the left, we show there is significant loss of capillary density, up to 95% loss of the smallest capillaries. And at the same time, on the lower left, significant increases in glycocalyx damage. So higher values of PBR, higher levels of glycocalyx damage in these healthy controls, or people exposed to COVID, I mean. Well, more recently, this was confirmed that it's not only in healthy adults suffering from COVID, and now some pilot studies also collected on individual children brought to the hospital in acute inflammatory complications called multi-system inflammatory syndrome related to the COVID virus. And these again show that in these children, on the right, there is a control patient that was in the hospital for surgery unrelated to COVID. And these two case controls show not only there's very high elevations in glycocalyx breakdown products in their plasma, so circulating glycocalyx polysaccharides like syndecan. So it's about almost a 10-fold increase in shedded glycocalyx in their plasma. At the same time, there's very significant increases in glycocalyx damage as measured with the Glycocheck device. So very high values for PBR. And again, confirming that in these children that are into the hospital because of the acute inflammatory symptoms of COVID, they have a very significant drop in their capillary density. So it's significant damage to their microvasculature, also in children that suffer from the acute complications of a COVID infection. Well, and then following up on another study that we presented last time is in diabetes. We've seen before that in diabetes, people with diabetes have a significant increase in their level of glycocalyx damage. And at the same time, if we do what's called a oral glucose tolerance test, so we ask the patients to drink a high glucose drink and then follow for 2 hours the response, for instance, in blood flow increases or in capillary density increases. We've noticed that in healthy controls, during the oral glucose tolerance test, there is a significant increase in blood flow due to nitric oxide increases, but also an increase in blood perfused capillaries. And in diabetes, we've seen that it's impaired because of a damaged microvasculature. During the glucose challenge, there's no increase in blood flow, there's no increase in nitric oxide, and there's no increase in capillary density. Well, this study was followed up recently and was presented in August at the Congress for the European Society for Cardiology by Dr. Economidis and his colleagues, again showing not only that in people with diabetes, but also in the middle column shows here even first-degree relatives of people with type 2 diabetes. So these people don't have actual type 2 diabetes, they're just first-degree relatives. And if you measure the nitric oxide responses in response to the oral glucose tolerance test, as compared to normal glycemic subjects, there's a 24% reduction in the amount of nitric oxide that's being produced during the oral glucose tolerance test. Similarly, in addition to the type 2 diabetics, even people with just elevated glucose levels, so not type 2 diabetics yet, also a strong reduction in their nitric oxide production in response to the oral glucose tolerance test. Even worse, there's another study just very recently presented is on people developing diabetes during pregnancy. So it's called gestational diabetes mellitus, GDM. The question that they addressed is whether people that show being sensitive for diabetics during pregnancy, how is their microcirculation doing even 10 years after giving birth? So they followed up these individuals for 10 years and showing that there's a strong decrease in microvascular health as measured with the Glycocheck device, even 10 years after giving birth for individuals that develop diabetes during pregnancy. So again, these findings, just follow-ups on the other clinical studies before, underline again that with the Glycocheck device, we over and over again confirm huge microvascular complications in a variety of diseases, but also that the damage is not easily repaired. So even 10 years after the challenge, people suffer from microvascular damage. And that's for diabetes. We've shown before in the previous podcast, even 2 years after COVID, there's very significant microvascular damage. And on top of that, we presented that not only we can predict in individuals with a poor microvasculature their risk for stroke, but even again confirming that people that are getting a stroke indeed have a very much compromised glycocalyx. So now knowing the risk associated with microvascular damage and how difficult it is to restore by yourself your microvascular health, how important it is to start working on ways and therapies to improve microvasculature and limit and minimize risk for future cardiovascular events in these individuals.
Wow, that's absolutely powerful in the aspect of 10 years later, they're still having these issues. Think about how many cells have turned over and turned over and turned over, yet they're still producing the same scars, the same damaged glycocalyx in the same areas. So clearly their resources to grow more are tapped. And so they're doing the best they can for 10 years, but clearly it's still not enough. So now the amazing aspect, or the good news, I should say, is that we can offer people leverage, give them more resources for their body to be able to overcome the damage that's continually happening to their system and be able to get a step up on that damage and actually turn it around and start to see healing and new hair growth or new glycocalyx in those damaged areas that you've been tracking for 10 years on end for so many of these people. So that's pretty powerful, because we would think that after damage, our body just heals it. Now we're proving that some damage can stay damaged indefinitely if we don't find the resources to overcome it.
You know, what's really exciting about what you're sharing, Hans, is obviously the whole world's just kind of come out of this whole COVID-19 pandemic that was global. And I think, you know, we were some of the first groups to publish papers on the impact of COVID-19 on the microcirculation. And because we were already positioned and had glycochecks in so many academic research hospitals around the world, some of those locations, in addition to the research they were already doing on the specific condition or disease that they were working on, also wanted to know what's the impact on COVID. And so, you know, what's really interesting, and I think you're going to get into this today on some studies that we're doing on COVID, but I think we're barely scratching the surface of seeing the damage to even healthy individuals that was done by COVID. So there's a condition that's in the news a lot now, it's long haul COVID. And so, you know, depending on which article you read, it's estimated that, you know, anywhere from probably 45 to 60% of people, and this is healthy people, that had COVID, even though they've had it and recovered, still have symptoms of long haul COVID. So, you know, brain fog. So it's affecting their brain function. Some of them, it's affecting their lung function. It's affecting their cardiovascular function. It's affecting their kidneys. We see neuropathy. Some people have the term COVID toe. We've seen that where people have difficulty with wound healing. And so I know you're going to touch on a couple of studies that we've done, but as Hans and I have talked to some of the researchers around the world, they're really concerned that in addition to all the other health problems that we have, so you think of cognitive decline, you think of kidney disease, you think of heart disease, you think of lung disease, all of those things, potentially an avalanche might have been triggered by COVID in that it's accelerating these diseases in people much faster. And so we're actually in quite a few studies right now trying to figure out what's the impact of those. So we live in exciting times, and the blessing we have is that, thank goodness, we have the technology to be able to know what's happening. And then also that we've got a product that we believe can make a difference in people's lives. So I think, Hans, you're going to talk more about that.
I definitely will. I just want to add that, as you showed, Bob, all the studies that are ongoing are shown on the website on Microvascular as well as on glycocheck.com. Many of the studies are, you know, long-term studies that we have just initiated, trying to help people recover faster from COVID, for instance, but also studies on cognition, study on heart failure, studies on hypertension. So all very exciting studies that will take some time to collect all the data and to be able to present. What I can share today is a couple of experimental studies that we have completed. There's a studies going on aging, for instance, and diabetes. And we have completed a study on the challenges by COVID. And that was recently published, so I can share a lot of those details. Let me start with the aging model that we have been studying and see how endocalyx can reduce many of the complications that we see with aging as well as in diabetes. So one of the factors I just discussed with you, that, you know, in aging and in diabetes, there is a strong reduction, not only in capillary density and damage to glycocalyx, but also a strong reduction in nitric oxide production and flow-mediated nitric oxide production. So all these factors were studied in an experimental study, and I'll show some of those data here with you. This study is completed and about to get published. So this slide shows, again, what we already know. This is about the numbers of vessels decreasing with age, as same as in diabetes, for instance. So on the left, it shows you how many blood vessels we have of the different diameter classes. So we measure in very small vessels, the true capillaries with diameters of 4 and 5 microns in diameter, up to larger diameters, up to 25 microns in diameter. But especially if you compare the blue dots, which are normal chow, older animals, compared to the gray dots, which are normal chow, young animals. So young animals, you see there's way more small vessels. There's a very significant drop in especially the smallest capillaries with aging. And that's consistent with the other data that we discussed last time also on the podcast, that even in healthy individuals with increased risk, for instance, due to aging, there's already a 50% drop of the number of smallest capillaries due to the risks that microvasculature is exposed to during age, and also because of hypertension and diabetes. So that's confirmed in this animal model. What's good to see in the middle panel, again, it shows you the blue dots of the normal chow, older animals, and together with the green dots. And the green dots are also old animals that have been using endocalyx for 8 weeks. So even after 8 weeks of adding endocalyx to the chow of these older animals, they restore their microvascular density back to normal healthy levels. And again, on the right, you saw that the young animals, both with and without the chow, still have high levels of capillary density. But the most amazing part is that in the older animals that used to have 50% reductions in capillary density is back to normal levels, even within 2 months taking endocalyx. Well, similarly, in these animals, we have been looking at different microvascular parameters related to glycocalyx. So again, if we measure glycocalyx thickness, comparing young mice to older mice, there's a very significant drop in glycocalyx thickness that's completely restored if you compare young and older mice eating endocalyx. Confirming that observation is if we measure glycocalyx damage again with the Glycocheck device and the PBR parameter for glycocalyx damage, we see there's significant age-induced damage of glycocalyx in the absence of endocalyx. And then using endocalyx, there is no difference anymore between PBR levels, low PBR levels, and low glycocalyx damage levels between young and older animals. Similarly, if we look at the red cell content in the capillaries, how much blood volume in the capillaries can be occupied by the red blood cells, there's significant loss of blood volume in the microvasculature with aging. Also, that is completely normalized by taking endocalyx in this model. Well, to finish this study, we also looked at how vessels dilate in response to different challenges, blood flow or endothelial-dependent vasodilator drugs like acetylcholine. And again, showing on the top left a big decrease in how far vessels can dilate. So people's blood vessels need to dilate to facilitate more blood flowing to the organs, and ensuring enough nutrients being delivered to the organs. An important part of that dilation in response to blood flow changes is due to glycocalyx. So what we find is that with aging, and comparing the gray dots with the blue dots, is a significant drop of the ability of your vessels to dilate and control blood flow to your organs. Well, the good thing is, if we feed the older animals endocalyx again, there's a complete normalization of the ability of your blood vessels to dilate and control blood flow to the organs. And then if we quantify that in terms of nitric oxide bioavailability, we see confirming again, as we saw also in the diabetic patients or in the first degree relatives of patients, this with aging, there is a very significant drop in your ability to produce nitric oxide. Now, with restoring glycocalyx, you see that there is a very significant normalization of your ability to produce nitric oxide and again, control blood flow. These data are again confirmed. On the lower left shows you the maximal level of vasodilation, so the maximal amount that your blood vessels can dilate and facilitate blood flow increases. A significant drop with aging, normalized by endocalyx. And again, showing that this increase is very much related to the ability of your endothelium to produce more nitric oxide due to a more healthy glycocalyx. So before I move on to the other data set on COVID, I just want to summarize and underline the importance of these findings. So we know that a lot of your microvascular functions are damaged over time, either just by aging or by exposed to challenges like diabetes. And for a long time, we didn't know there was anything we could do to stabilize that or slow down that progression. Now, these studies show very exciting data that not only we can slow down the loss of function and slow down the level of damage that people are having with age, but we can actually normalize in a relatively short period of time all these functions and get your vascular system back in shape as it used to be when we were young. So I think these findings are very hopeful and give great promise for the ongoing clinical studies in humans. We have seen some preliminary data that are very hopeful. I cannot share them, unfortunately, yet, because they're still ongoing, but also confirming these findings that we see in the experimental studies, also in even older individuals. So that's great hope of being able to modify and optimize your microvascular health using endocalyx.
So the exciting thing, Hans, is because of that study you just shared, that actually led to a follow-on study in conjunction with that group, but with another group we've worked with for several years. They're actually doing an anti-aging study on patients that's funded by the VA. And that's the one that I referenced that we're actually doing, that we needed to do the investigational new drug app for, because the VA is very interested in reducing the cost, number one, that they put out for these patients as it relates to all the complications of diabetes and hypertension, all of the, I guess, the storm of symptoms that explode as a person gets older with these things. So it becomes very costly, but also they're interested in improving these people's health. And it also has an exercise element to it to show that they can improve their, not only the things that you just talked about, that's part of what they'll be measuring, but they're also looking to see how it improves with exercise and how it improves their exercise performance. So, lots of times people say, well, why does it take so long? But, that study, I mean, we started on that study Hans just showed you, gosh, back in 2013, maybe. That's a long time ago. And the study I just mentioned, that's in humans, it sort of replicate a lot of what you just saw, only in humans. That's a 4-year study that's funded by the VA and the government. To get true double-blind placebo peer-reviewed studies, the studies that we're doing are very similar to what they do with drugs, which is kind of unusual for a nutraceutical.
Well, I tell you, I've seen a lot of things on anti-aging, and people talk about anti-aging. I've never seen anything that was just that straightforward. You have young, you have old, and in every way that you're looking at it, the old became young once again. And I can't think of how simple that formula is. There's so many different ways that people try to turn that clock back around. But like you said, life is in the blood. And if we're not able to improve that blood flow, you're not going to be able to truly impact all the tissues and cells and everything else in the body the way that you need to if you're reversing aging. So this truly is a gift. Absolutely.
Yeah. So like I said in the beginning, that's why we're so thankful to be involved in this. And as I said, it's amazing to me every day that as we fix this one thing, the true impact that has on allowing the body to restore itself. And that's true anti-aging from the inside out.
Yeah, absolutely.
Well, and just to follow up, I know in the previous podcast, we talked a lot about COVID. There's a lot of damage to glycocalyx in COVID, causing a lot of microvascular capillary density loss and increased damage to glycocalyx that we know is related to increased coagulation, increased inflammation, and increased leakage of fluid and proteins out of the vascular system over the endothelium, accumulating in the tissues, but also allowing more larger molecules like cholesterol leak into the vessels, so increasing all the risks of all the problems related to cholesterol, atherosclerosis, coagulation disorders, inflammation disorders. I'm very happy that we were able to do a study that directly addressing all these problems with the endothelium as soon as glycocalyx is compromised by COVID toxins that are in the plasma of patients that are really sick, critically sick in the ICU with COVID. And that paper was recently published, so I'm going to share some of those most exciting findings of that study. This is a study on cultured endothelial cells. So what the study did was they took blood samples from different people. So they took blood samples from healthy controls, for instance. They took blood samples for people with COVID that didn't get sick and didn't need to go to the ICU. And they took blood samples from people that got really sick during COVID and needed to stay in the ICU. So one thing they measured was the impact of these different blood samples, the different plasma samples on glycocalyx dimension. So what's shown here on the top left is a cross-section of the endothelium stained for glycocalyx with confocal microscopy. So this is an endothelial cell. On top would be where the blood is flowing. You go down, and then the green dye is a lectin stain for glycocalyx. So by measuring how much green dye is present on top of the endothelium, and the endothelium is here depicted in blue, you can measure how much glycocalyx is present, but also measure the dimension and the volume of glycocalyx. So what it shows in the pictures from top to bottom, when you have healthy endothelium exposed to blood plasma samples from healthy controls, you have a very well-established and thick glycocalyx on top. Similarly, if you take blood samples from people with COVID that do not get sick and do not need to go to the ICU, so non-ICU COVID patients, there's still a very significant glycocalyx present on your endothelial cells. However, if you take a blood sample from a person that really got sick from the COVID, you see there's a lot of bad stuff in blood circulating in these individuals. And if you take a blood sample and expose the endothelium to that blood sample, almost all of your glycocalyx is wiped off of your endothelial cells. And that's quantitated in the lower left. Here again, you see the staining for glycocalyx. So high levels of glycocalyx in endothelial cells exposed to control plasma or plasma from non-sick COVID patients. But if you take a blood sample from really sick people, whatever's in there is really breaking down your glycocalyx. And it's almost completely abolished after exposure to those plasma samples. Well, at the same time, if you look at the column here on the right-hand side, here we measured the permeability. So how leaky are your endothelial cells over time? So this is measurements done for a few hours. Again, endothelial cells were cultured, and you measure the resistance against leakage of your endothelial cells. So the higher, the better. So then they form a very tight coating on the inside of your vessels that doesn't allow leakage of fluid and proteins. However, as soon as you start exposing your endothelial cells to toxic plasma from very sick COVID patients, there's a very significant drop in the resistance of your endothelium, meaning there's a very sharp increase in the leakiness of your vessels. And it's measured in different ways, again, confirming that the resistance in endothelium with a damaged glycocalyx is significantly reduced, causing a lot of leakage of fluids and larger molecules, and having the endothelium very well exposed to all kinds of problems. However, if we look what we can do with endocalyx, so here we show again the dimensions of glycocalyx was significantly reduced by the COVID exposure. The main polysaccharide in endocalyx is fucoidin. So the endocalyx and the fucoidin, if we use that to treat the endothelium prior to the exposure or even after the exposure to the toxic COVID plasma, we see that we can normalize glycocalyx dimensions again. And not only can we restore glycocalyx dimensions back to normal and prevent the damage induced by the COVID plasma, also the complications that you would get because of a damaged glycocalyx can be prevented. So on the top right, we measured coagulation. So actually the anti-coagulation properties of the endothelium. A healthy endothelium prevents coagulation, and it's a great protection against clotting of blood cells and platelets on the endothelium. And that level of anticoagulation is compromised by endothelium with a damaged glycocalyx in COVID. And using the endocalyx, you completely restore your anticoagulation properties of your endothelium. So you prevent blood from clotting to your blood vessel wall if you restore your glycocalyx with endocalyx. Well, similarly, if we look at inflammation and the expression of inflammation adhesion molecules on the endothelium, we see that people exposed, endothelium exposed to plasma from sick ICU patients, there's a significant increase in inflammation adhesion molecules on the endothelium, which can be completely prevented by treating your endothelium with endocalyx. And also some other inflammatory transcription factors, NF-kappa beta. There's a significant increase in inflammation of your endothelium, and then they can be completely prevented by exposing and treating your endothelium with endocalyx. So these are acute data on all the damage that is seen on glycocalyx and endothelium by exposing your blood vessel wall to plasma from COVID patients. And the exciting thing is that all the damage that we have seen is repairable with endocalyx. So we can prevent loss of your glycocalyx dimension. We can prevent the leakiness of your endothelium. We can prevent the activation of coagulation, which is a huge problem in people exposed to COVID. And we can prevent all the inflammatory problems that we've seen in the adults, but also seen in the children that we just discussed in the ICU. So there's very, very great potential of endocalyx helping your vascular system to repair and protect against all these challenges. So we are full confidence that all the clinical trials that we have just started. So we have started a couple of studies on helping people, a clinical trial on individuals exposed to COVID when they are recovering from COVID, go home, and we do follow-up. We give them endocalyx, and we do follow-ups to see if we can actually help them repair their microvasculature much better than the other data that we collected, showing that individuals that are not treated still after 2 years have very significant levels of glycocalyx damage and a high risk of all the complications that we discussed. Similarly, as I mentioned before, doing studies in diabetes, doing studies in hypertension, doing studies in heart failure, doing studies in cognition impairment. So I hope, Mark, that similar as the very, very simple ways to show the anti-aging effects of the endocalyx, that we'll find very similar effects in all these clinical trials that are ongoing in line with the data that we just published on protecting against the COVID challenges.
Well, seeing all that data certainly helps me understand why you guys have felt so confident traveling all over the world these last 2 years in this pandemic. And so you've seen the science, you understand that we can heal from this, and the damage that we've been exposed to doesn't mean it necessarily has to be permanent damage. Our bodies are amazing and they're resilient, and given the right resources, they can certainly overcome some pretty devastating damage. It was a very exciting episode. I thank you so much. We can just sit here and listen to this all day, but I think we need to save some for next time when we have everybody back on again with their new cameras. And basically I see, the hundreds of doctors coming on with this Glycocheck is going to be able to give us so much more data to know that much more about the amazing things that are transpiring inside individuals that are using this amazing product. So I'm looking forward to being part of the contribution to that database and scanning a lot of people and being able to find ways to get them healthier than they've been in a long time.
Yeah, it's exciting times. So, I'm so excited that in 2023, we're going to be able to build up the network of Glycocheck locations so that patients can search and find a location where they can go get tested. We get requests from people all the time, is there a closer location, or how can I get tested? And there's huge interest in this, and this is going to be a big blessing for all those people that, don't really have a place to turn. And I think as you release this video to people, it's going to be a real eye-opening experience to see the impact of the level of studies that we're doing, but more importantly, that there's real hope for people, that it's not too late. Because, that's the biggest question that people started asking me a long time ago is it too late? Because all too often when they go and talk with their doctor, and I love your acronym of the good news doctor. I've always loved it since the day I met you, because most people are used to bad news when they go to the doctor. But I love, that you call yourself the good news doctor. And this is really good news that needs to be shouted from every rooftop.
Absolutely. Yeah. Thank you so much for that. And hence the good news doctor is why I am what I am and why I do what I do. And so too many people just don't get enough good news in the day. And so we are that news. We are the people that are going to make this part of everybody's day the best part of their day, because now they feel hope again and they feel empowered that we can get healthier and we can reverse aging. There's so many amazing ways to do it, but this is truly the foundational way that if we're not tapping into this aspect of it, we're really missing the boat. So thank you, gentlemen. I appreciate you coming on and sharing the good news with us. And until next time, you guys have a great day. And thank you all the listeners for joining us today. And until next time, have a wonderful day and keep enjoying sharing the good news. Talk to you later. Bye-bye now.